Welcome to Module 2, Building a Database and Defining Table Relationships Concepts video. Databases are a great tool for organizing and storing data, but before actually creating one, careful attention must be paid to the actual design of it so it meets the needs of the user. Developing an effective database will require you to fully identify all the data, or fields in this case, needed to produce the required information. Recall, data is a valuable asset, and data can be turned into even more valuable information in the form of queries and reports. For example, we need to design a very simple database for Joe's automotive shop. After looking over his current records and the way his shop does business, we have identified 7 fields we need to use in creating the database: customer name, customer address, customer phone, invoice date, invoice amount, and vehicle. Now, after we identify the fields needed, we need to make sure that every field is currently in its smallest, most useful part. So what does that mean exactly? Let's take customer name first. Customer name implies that the field will contain both a customer's first and last name. This field actually should be divided so that one field contains the first name and the second field contains the last name. So why is this important? Primarily so that we can sort our customers. Typically, customers will be sorted by last name. If we have a field with the entire name in it, it's going to be very difficult to accomplish any type of sorts using a last name. So as a general rule, if a person's name is stored in the table, you should always separate it and create a first and last name field. So looking over our list, what other fields should be organized into smaller parts? Looking at customer address, this too implies more than one part involved. An address will include a street address, city, state, and zip code. So with that in mind, we should be able to divide that field into 4 separate fields. Again, using street address, city, state, and zip code. Looking at the other fields, we could also make an argument to separate the vehicle field into separate parts, such as make, model, and year, which again, as a general rule, should be done, but for simplicity's sake, we'll leave that field as is. With our data now organized into its smallest, most useful part, we end up with 10 fields for our database: customer first, customer last, street address, city, state, zip code, customer phone, invoice date, vehicle, invoice amount, and work performed. So once our data is organized, the next step is to group related fields together. These groupings will become the actual tables for our database, or more appropriately, the fields for our tables. Now, looking at the organized data, attributes about customers really stand out. We have customer first, customer last, street address, city, state, zip code, and customer phone. These fields can be grouped together to form our customer table. The fields that remain, invoice date, vehicle, invoice amount, and work performed, relate to each other. These fields represent work performed for the customer on their vehicle. So these fields can be grouped together to form an invoice table. Now, with this step completed, our simple database contains 2 tables, a customer table and an invoice table. The golden rule of database design is that every table requires a primary key. Why? Because a primary key will uniquely identify each record in a table. This is important for 2 reasons. First, to maintain database integrity, and second, to avoid data redundancy. Now, the book will tell you to determine each table's primary key based on the fields that are there. In the customer table, there may be multiple customers with the same last name or first name, so either one of those 2 fields wouldn't do. Their addresses may be different though, so what about that for a primary key? Well, you have to consider everything. What if an existing customer moves to a new address and another existing customer moves into that old address? That field will no longer uniquely identify the customer. But you might say, well, the customer that moved has a new address. Why wouldn't that work? Because number one, it violates one of the rules about primary keys. They cannot change. And we're going to be learning more about that in the coming weeks. So what about using 2 or 3 fields as a primary key? This is what's called a composite key. For example, we could potentially use first and last name together as a composite key, but if you have 2 Joe Smiths, the records won't be unique. Maybe we could use another field. Say, incorporate address to first and last name. Now, granted, it's a super long shot that a customer with the same first and last name would ever live at the same address. When you go beyond 2 fields as a composite key, your primary key is becoming too large. So you want to make sure that you don't get too large with a primary key. Having been a database developer for years, my suggestion is that you should always create a primary key for a table. Don't rely on any fields that are existing there. Just create a new one instead. So for these 2 tables, we need to create primary keys for each. I would create a customer ID as a primary key and an invoice ID as a primary key for the invoice table. Now that our tables are set up and contain primary keys, the next step is to determine how the 2 tables relate to each other. At Joe's Automotive, a customer can bring their car in once, or they can bring in their car many times for service. Taking it a step further, if they really like the service they receive, they can bring in all of their cars many times for service. Service in this case is in the form of an invoice, which is represented by the invoice table. With this in mind, one customer can have many invoices, and the relationship between the 2 tables, therefore, is what's called a one-to-many relationship. To create the relationship between the 2 tables, we need to include a common field in the related table. The related table in a one-to-many relationship is the many table. For our simple database, this will be the invoice table. The common field is also known as a foreign key, and the foreign key will be related to the primary key in the one table. With this database, we would add customer ID as a foreign key in the invoice table. By doing this, a customer can have many invoices in the invoice table. The rule with a one-to-many relationship. In the one table, there can be no records, one record, or many records related to it in the many table. And in the many table, each record will be related to exactly one record in the one table. After adding a foreign key in the many table, we can create a relationship between the 2 tables. Doing so will enforce referential integrity, and this helps ensure that you cannot enter a record in the invoice table using a customer ID that doesn't exist in the customer table. When you create a relationship between the primary key in the one table and foreign key in the many table, 2 rules must be followed. Number 1, the foreign key must be the same data type as the primary key. And 2, the foreign key data type must be the same field size as the primary key. If any or both of those rules aren't followed, Access will show an error message when trying to create the relationship. Another general rule of common sense about foreign keys, they should have the same name as the primary key they're related to. It makes it a no-brainer creating the relationships between the fields if they have the same name. Now that the tables and relationships have been designed, the next step is deciding how to set up the fields in the tables. In the first module, you created a table in Datasheet view. To be honest, building a table in Datasheet view is, at least to me, an exercise in complete futility. From here on, we will use Design View to create and modify our tables. In Design View, it's easy to create field names, select data types, and set field properties. In Table Design View, at the top, you will see the field grid. Within this grid, you'll add field names, select the field data types, and can also add an optional description for the field. When you name a field, if it has more than one word in the name, do not include a space between the words. Instead, capitalize the first letter of each word. This is referred to as camel case notation. Now, before I mention data types, the description section of the grid will never be seen by a database user. The description section is there for the developer to add notes or description of what the purpose of the field is. Going back to data types, Setting them for a field is the most important part of building a table, especially where primary and foreign keys are concerned. There are 8 common data types in Access: short text, long text, number, date time, currency, auto number, yes, no, and hyperlink. The properties each data type possesses is shown here within the table. With all the data types, you can set both the format of it and the caption for the field. Formatting for the various data types have either preset formats, such as dates and numbers, and/or can be set up with a custom format. Now the caption property, if set, will be what shows at the top of the column in a data sheet or label in a form. So if your field has camel case name, such as customer ID as one word, you can give it a caption property of customer ID with a space between the 2 words. Captions make a database more user-friendly. The default value is also a user-friendly property. With it, you can specify a value for the field if it's typically the same every time, such as a state field, or a date field, setting it to today's date. Field sizes are specific to 3 data types: short text, number, and auto number. And these are typically used as primary keys in a table. So if you create a foreign key in another table, again, as I've mentioned, it has to be the same data type and size as the related primary key. Example, if customer ID is a short text field that's size 4 in the customer table, customer ID in the invoice table must also be short text size 4. As a side note, throughout the book, the databases we're going to be using have the primary key set as a short text data type. In the real world, it's a much better idea to use an auto number data type for a primary key. Using an auto number guarantees that the primary key value will be unique, and you never have to rely on a user to enter a primary key value. When it's short text, the user will need to enter the value, and that frankly can cause problems. When you use an auto number data type for a primary key, the foreign key in the related table should be set to the number data type, and you want to leave it with its default size of long integer, because this is going to match how it auto numbers default size is set. Speaking of default sizes, when working with short text data types, as a best practice, you should always change its size. The default size for short text fields are 255 characters. That's a lot of characters, and if left as is, Access is going to reserve that much space in memory for each field value. Consider this: if you have a state field that are only going to contain abbreviations, 2 characters in length, and you leave the field size set at 255, there's going to be room in memory for 253 extra characters for every state entry. It might not sound like a lot, but if you have 1,000,000 state entries, that's going to amount to 253 million bits of wasted space on your hard drive. So when you create a short text field, adjust the field size so that it will accommodate at most the largest possible entry into the field. Save your storage. So that'll do it for the Module 2 concepts. The next video will go over Module 2 skills. After finishing these 2 videos, take the quiz while the material is still fresh. Remember, if you need to review a concept or skill, use the rewind button and go over the material you see fit.